Hello, myself Neelam Ramesh. I am working as an assistant professor in Laxman Reddy Institute of Technology and Management. So today we are going to discuss about lasers systems. So from the laser systems, we are selected Ruby laser to discuss today. So let's go to the discussion. So before going to discuss about the laser, so first we are going to discuss about what is meant by laser and some important concepts about laser. First, let us discuss. This is the acronym of laser. So which stands light amplification by stimulated emission of radiation. So which means light get amplified by the process called stimulated emission, and finally radiation comes as an output. So here amplification is nothing but the process of increasing the strength of signal, and this amplification takes place by the process called stimulated emission, and finally radiation comes out here. So like this the laser emission takes place. So this is the full form of laser, we can say here. So next to that, so laser is a device that amplifies or increases the intensity of light, produces high directional light. So as I told you, we know that laser light is completely different from the other light sources what we are using in our regular life. So why? Because the lasers are having some particular different characteristics, like its intensity, output, and directionality, and a single color availability, so and coherence. So like that there are different characteristics are there for laser. So that is the reason lasers are becoming that much very important in every engineering stream and every technical stream. So now let us discuss about some important characteristics of laser here. The first characteristic here we are going to discuss is about monochromaticity. So monochromatic. So lasers are highly monochromatic in nature. So monochromatic is nothing but the light which consisting of single wavelength or color. So such type of lights we can call as monochromatic in nature. So here the lasers are also highly monochromatic in nature. So they consisting of single wavelength. They doesn't consist multiple wavelengths here. And the next characteristic we are going to discuss is nothing but directivity. So directivity is nothing but, we know that when you switch on the laser light can travel to long distances with low deviation. So straight they can travel. So the normal lights, if you switch on, the light can spread throughout the space within short period of time. But laser light, if you switch on, the light cannot be spreaded in all directions. Okay, so laser beams are emitted in specific direction. So that's why the directionality is high for lasers here. Next characteristic is coherence. So coherence is nothing but same phase difference or constant phase difference the light rays maintains. When you switch on the laser light waves travels with constant phase difference here. So that is also one of the important characteristic of laser, we can say. Next one is collimation. So collimation is nothing but the parallel to each other. The waves or rays which are emitting from laser source, those waves are parallel to each other and they are traveling in same phase difference they travels. So that is nothing but collimation, we can say. And the next one is output power. So the output power also very high in laser systems. So the average output power of laser is often quoted in units of milliwatts, watts or kilowatts. So that much powerful output we can achieve from laser sources here. So now next to the characteristics of laser, so let us come to our topic Ruby laser today. So under Ruby laser, first we are going to discuss about the history. Okay, so when it was discovered and who discovered Ruby laser, all the things we will discuss under history. And the next, construction. So how can we construct Ruby laser, all the things we will discuss. And next, principle and working. Okay, how the Ruby laser works and what is the working principle of Ruby laser, all the things we will discuss under this. And applications. So where can we use Ruby laser, all those things we can discuss under applications. And finally, drawbacks. Okay, so the drawbacks of Ruby laser also finally we can discuss here. So now let us discuss about the history of Ruby laser. Let us discuss. So here Ruby laser is a solid state laser system, so invented by the person called T.H. Myman. In the year of 1960 he invented this Ruby laser system. So Ruby laser is a first invented laser system experimentally. So in Herc's research laboratories in the year of 1960, the person called T.H. Myman, first he fabricated or invented experimentally equipped ruby laser system here. So next, as I told you, ruby laser is a solid state laser because the active medium in ruby laser is a ruby crystal. The active medium is a solid, that's why this laser can be called as a solid state laser here. So next, the ruby laser is used where high powered pulsed output is required. So the output laser from ruby laser is a pulsed mode laser we can get. So the laser output is in pulsed mode. So pulsed mode in the sense continuous laser output we cannot achieve from ruby laser system here. So that's why it is called pulsed mode laser also. So next one, ruby laser employs 3-level laser scheme. So 3-level laser scheme in the sense, so 3 energy levels involves in lasing action of ruby laser here. So there are several level schemes are there, 2-level laser scheme, 3-level laser scheme, 4-level laser scheme, and etc. So coming to our ruby laser, so ruby laser works with 3-level laser scheme here. So that we will discuss in the next upcoming slides. What is 3-level laser scheme? All the things we will discuss. And finally, ruby laser employs optical pumping method. So pumping method. So pumping mechanism is nothing but the process we are providing external energy to excite the particles or atoms from lower energy levels to higher energy levels. Okay, so that external energy we can apply to the active medium in the form of light. Optical pumping we are using. So optical pumping is nothing but with application of light energy, if you excite the atoms from lower energy levels to higher energy levels in the sense. Such type of pumping method we can call as optical pumping method here. So here in our ruby laser, we are using optical pumping method. So now coming to the construction. So construction of ruby laser, let us see. Here in this image, you can see that the construction of ruby laser. Here this rod is nothing but, so this is ruby rod. So the active medium we are using, this is ruby rod, and this yellow helical flash lamp is there now. So this is nothing but helical xenon flash lamp we are using. So the purpose of using flash lamp is to provide optical pumping to the active medium. So as I told you, optical pumping we are using. So to provide the light energy, we are using this helical xenon flash lamp here. So inside the xenon flash lamp, we are inserting the ruby rod. So when you switch on the ruby rod, so ruby rod, when you switch on the ruby rod, when you switch on the flash lamp, so flash lamp emits light. So this light can be absorbed by the particles which are presented in ruby rod. So these particles absorbs the light energy and excites from lower energy levels to higher energy levels. From those higher energy levels, while they are coming to ground level, in between population inversion achieves in metastable state. So later from the metastable state, while the atoms are coming to ground level, they emits their excess energy in the form of photons here. So that takes place here. So here you can see, so ruby laser consisting of a single ruby rod crystal, and this ruby rod size is 5 centimeter length and 0.5 centimeter diameter. Okay, the size of ruby rod we are using in the experiment is 5 centimeter length and 0.5 centimeter diameter size ruby rod we are using in our experiment here. Okay, and the surfaces and ends of the ruby rod will be plane and parallel. So next, so if you observe here, the ruby rod, the both ends. So the both ends of ruby rod, if you observe in this figure, so the ruby rod separately you can see here. So in this figure, we are having two ends. So this is one end and this is another end. So this is totally reflective mirror. So totally reflective in the sense 100% coated with silver. So one side of ruby rod, to the one side of ruby rod, here I am applying 100% silver coating. To the other end of ruby rod, I am applying partial silver coating. So that's why here it was mentioned as partially reflective mirror. So like that, the two mirrors we are arranging at the to the both ends of ruby rod. So one is fully reflective, another one is partially reflective. And here this is nothing but flash lamp setup. So when flash lamp is switched on, the light incidence on ruby rod, the particles absorbs that light energy and excites to higher energy levels, and some transitions takes place in between energy levels, and finally photons are get emitted from the partially coated mirror as output here. Okay, so that's why we are making the one end of ruby rod as 100% coated with silver and other end will be partially coated with silver. The ruby rod is placed inside the xenon flash lamp as I told you. So inside the helical xenon flash lamp we are inserting the ruby rod here. So here you can see the figure. So here in this figure clearly you can see that. So here this is nothing but our ruby rod. Okay, so to the ruby rod, one is fully reflective and another one is partially reflective. So fully reflective in the sense, so 100% coated with silver, this mirror. So this mirror is partially coated with silver. So whenever photons are incidented on this ruby rod, by switch oning the flash lamp, photons incidence on ruby rod, and these atoms, whatever we mentioned here in E1, E2, E3. So these particles are initially in E1 ground state. So whenever we are incidenting some photons, so photons are nothing but flash lamp. From flash lamp, light energy incidents on the atoms in ground level. So these atoms in ground level absorbs the photons and excites from lower energy levels to higher energy level here. From E1 to E3 they excites. So like that the population increases in the higher energy state now. So later on that, so these atoms are not going to stay permanently in the higher energy level. So after their lifetime, again they need to de-excite to the next lower levels. So that's why these atoms will de-excite to the next lower level called E2 here. So that's why the population is increasing in E2. The atoms which are there in E3 level, these atoms are de-excited to the E2 level. So here E2 level is called metastable state. So here E2 level we can call as metastable state here. So what is mean by metastable state in the sense? So metastable state is a level which is having long lifetime. So comparing to higher energy level, so E2 level is having long lifetime. So that is the reason the atoms which are coming from E3 level to E2 level, so these atoms accumulates, so gathers in E2 level. Because of long lifetime, the atoms which are coming from E3, so they stays more time in E2 level here. So that is the reason the population inversion takes place between E1 and E2 level here. So where E1 is the ground state and E2 is the higher energy level. So population inversion. So what is mean by population inversion in the sense? So generally by default the population should be high in the ground state. But here this process is becoming reverse. Okay, so that's why the population is increasing in higher level comparing to lower level here. So that's why here this process we can call it as a population inversion process. So now because of this population inversion process, the number of atoms are increasing in the higher energy level E2 than E1. So then after, so for example here this energy level lifetime is around 10 power minus 9 seconds in the sense the metastable state lifetime should be around 10 power minus 3 seconds here. So that is the reason the atoms can stay for some more extra time in the metastable state. So then after lifetime of atoms in metastable state, these atoms while they are coming to ground state, so in metastable also they won't stay permanently. So from there also they need to come down after 10 power minus 3 seconds. That is the reason while these photons are coming to next level E1, so they releases their excess energy in the form of photons. So photons are nothing but laser photons emits in between E2 and E1 level. So bulk number of atoms are coming from E2 level to E1 level here. That is the reason. So more number of photons can be emitted in this transition between E2 and E1 here. So that's why population inversion is very important in lasing action. So when population inversion achieves, then only in between those energy levels maximum number of photons can get emitted. So that's why population inversion is very important in lasing action here. So like this in ruby laser also the process takes place here. Okay, so inside the ruby rod, So this type of mechanism, what we shown here. So this mechanism takes place here. So inside the ruby rod, whatever the chromium particles are there, these chromium particles excites to higher energy level by absorbing these photons. So then population increases in the higher energy level. So then after lifetime, these photons comes to metastable state. So in metastable state, population increases. So and population inversion achieves. Then after, while they are coming to ground state, they releases photons or laser photons here. Okay, so this is the major process taking place in ruby laser system here. So next see. So what is ruby rod and what it consisting of? Let us see. So ruby rod consisting of Al2O3, aluminum trioxide. So ruby rod is a aluminum trioxide crystal and consisting of chromium particles as impurities in aluminum trioxide crystal. So in aluminum trioxide crystal, some of the aluminum ions are replaced with chromium ions here. So how many in the sense? Around 0.05% of aluminum ions are replaced with chromium ions. Okay, so that's why chromium particles are presented as impurities in aluminum trioxide crystal. So this crystal we can call as ruby rod. Our active medium here it is. So now let us see the energy level diagram. Okay, so now we saw the construction and working of ruby laser. So let us see how the energy levels are presented in ruby laser, and in between those energy levels how the atomic transitions are taking place and how the laser emission takes place. Let us see now. So energy level diagram, if you observe, so here this is the energy level diagram of ruby laser, you can see. So first here this is the ground state. Okay, so initially the atoms are presented in the ground state here. So for these atoms, whenever we are providing some external energy, so in ruby laser, how we are providing external energy? In the form of light. So when you switch on the flash lamp, the light incidents on ruby rod and chromium particles which are presented in ruby rod, they absorbs these photons and excites from lower energy levels to higher energy levels like this here. So here these two are the lower energy level and higher energy level. So this is 4F1 and 4F2 energy levels names. Okay, so blue absorption and green absorption. So from the light of a flash lamp, chromium particles, some particles absorbs blue wavelength and some particles absorbs green wavelength, and they excites to their corresponding energy levels here. So now the particles are presented in 4F1 and 4F2 energy levels here by absorbing some energy. So now these atoms cannot stay permanently in those higher energy levels 4F1 and 4F2. They need to come down after their lifetime. So that's the reason. So they de-excites from their higher energy levels to metastable state. So here metastable state we can mention it as 2E. So the metastable state is 2E. So these atoms from higher energy levels 4F1 and 4F2, they de-excites to metastable state here. So what is metastable state? So just now I told that metastable state is nothing but the state which is having long lifetime. Okay. So because of long lifetime, the atoms which are coming from 4F1 and 4F2, they stays more time in metastable state here. So then the population inversion achieves between E1 and E2 here. For example, if you consider this as E1, metastable state as E2 in the sense, so comparing to E1, the population will be high in E2 level here. So like that, the population inversion achieves between E2 and E1 levels now. So next to that, so from this metastable state, these atoms will de-excites to ground state after lifetime of metastable state here. So while they are de-exciting, so these atoms emits their excess energy in the form of photons. So how much intensity of laser we can achieve in this transition? In the sense, it is around 694.3 nanometer laser intensity we can achieve in ruby laser system here. So generally we can get R1, R2 two intensities. Okay, so from R1 and R2, so 694.3 and 694.2 I think. So from those, the highest value is 694.3. So that is the reason the output of ruby laser is how much? In the sense, we can consider the value of 694.3 nanometer here. So now let us see. So as I told you, the explanation of energy level diagram you can see here. So there are main pump bands, so 4F1 and 4F2, okay, which is having the lifetime around 10 power minus 9 seconds. So you can see, so as I told, so this is 4F1 and this is 4F2, higher energy levels. So the atoms in the ground level, they absorbs the light energy and excites from here to here. From ground state to higher energy levels, they will excite. The pumping method, the pumping process takes place like this. So next, after this, chromium ions gets excited to these levels by absorbing energy from xenon flash lamp. So there is fast non-radiative decay from these bands to 2e level. So by optical pumping method, so the atoms in these levels excites to higher energy levels here. So from these energy levels, by non-radiative process. So what is mean by non-radiative? So the non-radiative process is nothing but, so while the atoms are de-exciting from higher energy levels to lower energy levels, they releases their excess energy in the form of phonons or heat energy. So such process we can call as non-radiative process. Or else if they are releasing their excess energy in the form of photons, in the sense such process you can call as radiative process. So radiative process takes place in between E2 and E1 here. From E2 to E1, the atoms while they are de-exciting, they are releasing their excess energy in the form of photons. That's why E2 to E1 process we can call as radiative transition, and 4F1, 4F1, 4F2 to 2E, this transition you can call as non-radiative transition. So that's why by non-radiative transition, chromium ions get excited to these levels by absorbing energy from xenon flash lamp. There is a fast non-radiative decay. So non-radiative decay is nothing but, so in this transition the energy emits in the form of heat or phonons. Okay, so that is non-radiative process in the sense. So you can see, so from here 4F1, 4F2, these atoms are coming to metastable state 2E by non-radiative process. So this 2E state is called as metastable state. So metastable state lifetime is around 10 power minus 3 seconds. So as I told you, the lifetime is more than higher energy level. So higher energy levels lifetime here it was mentioned around 10 power minus 9 seconds. But for metastable state, the lifetime is around 10 power minus 3 seconds. Here it was mentioned. So next, thus population inversion achieves between 2E and ground state here. So what is 2E? So 2E is nothing but metastable state. So the atoms are accumulating in metastable state and population inversion achieves between 2E level and ground level. Okay. So the transition by emitting a sharp doublet. So R1 and R2. So from this metastable state, while the atoms are coming to ground state, they emits the photons. So two laser intensities you can observe. So one is 694.3 angstroms and 6928 angstroms and 6943 angstroms. Here it was mentioned. So from these two, the highest value is 694.3 nanometer. So angstroms are nanometer, so the units are different. So that's why the highest value you can consider as a ruby laser output here. So two values, so two laser intensities we can achieve in this transition between metastable state to ground state, but highest value we will consider. That's why the laser emission of ruby laser we can mention as 6943 angstrom, 6943 angstrom here. So thus the energy level diagram we can explain. So the atomic transition takes place between energy levels in this process here. So now next, coming to the applications. So where we can use the application, where we can use this ruby laser in the sense, so the applications of ruby laser, so the first application is nothing but in holography. So in holography, to create holographic images, we can use ruby laser systems here first. And next one, so the non-destructive testing labs, by using ruby lasers to create holograms of large objects such as aircraft tires. Okay, so like that much of large images also we can construct by using ruby laser system here. This is also hologram application only. And ruby lasers are extensively in tattoo and hair removal process. Okay, so in tattoo removal process and hair removal process, and in some other medical applications also, we can use ruby lasers here. So these are some major applications of ruby laser, we can say. And next to the applications, now let us come to the drawbacks. So what are the drawbacks of ruby laser? So because ruby laser is a first experimentally constructed laser system, so it is having some drawbacks also. So later on in next days, so many people worked on these constructions of laser systems, and they developed so many advanced laser systems also. So now coming to our drawbacks of our ruby laser. So the ruby laser requires high pumping power. Okay, so to excite the chromium particles from lower energy level to higher energy level, so we must apply some high pumping power. So pumping, how we can do here? By optical pumping. So much optical pumping is required to pump the atoms from lower energy levels to higher energy levels in ruby laser here. And next, the other drawback is the efficiency of ruby laser is low. Okay, the efficiency is also very low. So nowadays high efficient laser sources are available for us. So because it is a first manufactured fabricated laser system, that's why comparing to the available laser sources, the efficiency is somewhat less in ruby laser here. And other one is the laser output is not continuous. As I told you, the ruby laser works in pulsed mode. So it doesn't emits laser beam continuously. Okay, continuous laser output we cannot achieve in ruby laser. So once some laser pulse was emitted, in the sense after some time delay other laser pulse comes out from the ruby laser here. Like that, ruby laser emits in the form of pulses. That's why it is called pulsed laser source also. Okay, after some microseconds another pulse will come out. So that is also one of the drawback of ruby laser, we can say here.